You're welcome to the Supernovas TV. I'm so happy to have you in class once more. I'm so delighted. Okay, you're joining us for the first time. Please do well to subscribe, okay, the YouTube channel and follow us on Facebook at the Supernovas Academy. Now, we're going to chemistry. We're going to treat the topic chemical bonding. Chemical bonding. Chemical bonding, otherwise known as chemical combination. Okay, most atoms or elements go into combination to attain stability. Elements go into bonding or combination to attain what? Stability. Stability is established by noble gases. Noble gases or rare gases. They don't need to react anymore. Okay? Noble gases attain stability by either duplet or octet configuration. Duplet stability by duplet or octet configuration. For example, helium. Helium, okay, helium is a noble gas that is stable. It has its inner electron shell having two electrons. It doesn't need any addition. It's already stable. Octet configuration. Example, neon. Neon has an inner shell having two electrons and an outer shell having what? 8 electrons. Okay, it's already stable. Now, all other elements try to be like the rare gases or noble gases by either accepting or losing electrons. Okay, metals ionize by losing electrons to become cations. Metals ionize, they lose what? Electrons to become cations. Non-metals ionize by gaining electrons. They gain electrons to become what? Anions. Now let's look at the types of chemical bonding or combination that can bring elements or atoms together. I'll rub this off. Okay. Types of chemical bonding. Types. There are two types. Okay. We have the interatomic bonding and we also have the intermolecular bonding. In the interatomic, atoms come together. Atom plus atom to give us what? Molecule. Okay? And due to the fact that they are concerned with atoms, they control the chemical properties of substances. Okay? Meanwhile, here, this one joins what? Molecules. And they control the physical properties. I hope you're enjoying the class. Once more, I invite you to follow us on Facebook at the Supernovas Academy and on YouTube at the Supernovas. Subscribe to the Supernovas TV. We teach physics, chemistry, mathematics here, and I make sure you understand perfectly. Now, we have different types or groups under the interatomic bond or combination. We have the ionic or electrovalent. bond. We have the pure covalent bond. We have the dative or coordinate covalent. Okay, and then we have the metallic bond. These are all under interatomic. Under the intermolecular, we have the hydrogen bond. Okay, we have also van der Waals forces, very popular but very weak forces. Van der Waals forces. And then we also have crystal lattice forces. Crystal lattice forces, which can be ionic or covalent. Now, in this class, we will try to explain the first type of bonding, the ionic electrovalent bonding. So I'll rub this off. So go ahead. Okay, we are looking at electrovalent or ionic bonding. This type of bonding is between a metal and a non-metal. This bonding results in the formation of ions, positive and negative ions. The metal is the electron donor. The non-metal is the electron receptor or receiver or acceptor. Okay? So, what happens in the ionic bonding? A metal loses its electron to a neighboring non-metal that is in need of that electron. Okay? And a kind of force of attraction is established due to the presence of those ions that are being released from the metal to the non-metal. Let's take for instance, formation, for example, formation of sodium chloride. This is a vivid example, NaCl. Now, if you're going to draw the outermost shell of, or you can draw both of them, sodium, which is 281. Okay, you can draw a very minute structure here. Okay, I hope you follow. Sorry, it's not very okay. Sodium 281. Let's put the other electron here. It's combining with chlorine. This is sodium, chlorine. Okay, chlorine is as here 287. The structure is something like this. Hope you follow. We have different representation. Okay. Now, these are 7 electrons in the outermost shell. What happens here is that sodium would lose this electron towards chlorine and becomes accepted by chlorine. when we have the new shell. I'll have to draw it. In the new shell now, in the new shell, I'll only draw the outermost shell, or both now. Sodium ion is formed. Okay, we now have two here. Okay, I'm not actually filling the electrons in order because I have to save time. Okay, this is now 2,8. It has lost this one electron. Okay, and then chlorine anion is formed. Okay, now has 8 complete. Chlorine anion is 288 now. So at the end of the day, we have sodium chloride formed here. That is what? NaCl. We can see now that there is ions here. There are ions. These ions now create a very strong bond of attraction between sodium and chlorine, which is termed the ionic or electrovalent bond. This is the reason why this bond is a bit strong, because it's between, okay, positive and negative, leading to the formation of a polar compound. Okay, polar compound. Take note that this type of bond is also formed when there is a large electronegativity difference. It's formed when there is a large electronegativity difference between the atoms. Remember, one is a metal, the other is a non-metal. So the metal is more electropositive, while the non-metal is more electronegative. So the electronegativity value is quite, the metal has a very low electronegativity value, while the non-metal has a very high electronegativity value. Okay, that establish that bond between those atoms that have ionic bond. Okay, so these compounds, electrovalent or ionic compounds, are solids at room temperature. Okay, they have high melting and boiling points due to the strong force of attraction. Okay, other compounds we can see, we can have CaCl2, calcium chloride, magnesium chloride. Okay, the many compounds we can get. Okay, we have magnesium oxide. Okay, many other elements or compounds we can get from this combination. Okay, under this type of combination, their reactions are also spontaneous because the presence of polar heads here, and then they dissolve in water, which is a polar solvent, but they don't dissolve, or they are insoluble in non-polar solvents like benzene, toluene, and coke, and others. Okay, they, like I said, okay, they are good conductors of electricity because of ions. There are free electrons here, okay, which can conduct electricity in aqueous medium. So these are, okay, this is under electrovalent or ionic bond. In the next class, we'll be going into covalent, pure covalent, and dative or coordinate covalent bond. Please do well to subscribe to our channel. I love you. See you in the next class.